In this video, we're going to look at the proof of the parallel line theorem. This proof draws on the different properties regarding the areas of triangles that we looked at in the previous video. The parallel line theorem states that a line drawn parallel to one side of a triangle, these are parallel lines, divides the other two sides in the same proportion. In other words, AP divided by PB is equal to AQ divided by QC. When we start our proof, we're first going to have a look at what has been given to us. So here we've been given this triangle with PQ, parallel to BC. Then what are we required to prove? That's our RTP. We are required to prove the proportionality, in other words, AP divided by PB is equal to AQ divided by QC. To start off our proof, we need to construct certain lines. So I'm going to join P and C. So I'm going to construct diagonals of what looks like a quadrilateral at the bottom of this triangle. I construct both the diagonals. What I'm also going to construct is altitudes. So I've got an altitude coming from vertex P that I'm going to construct. And then I've also got an altitude coming from point Q, which I'm going to construct. And then I'm going to call the one H and call the other one K. Now, when I've done a construction, I do need to write what I've constructed. So to start off, I'm going to say construct PC and QB and altitudes H and K. And I'm going to look at the area of various triangles. So I'm going to start off by looking at the area of APQ divided by the area of BPQ. Now notice for both those triangles the altitude is K. So I'm going to start with the area of triangle APQ divided by the area of triangle BPQ. Now remember, the area of a triangle is half base times altitude. So I've got half, and the base in APQ is AP. And I've already shown you that we're taking the altitude of K. So it's half AP times K, and the area of triangle BPQ is half times the base is PB, and the altitude is K. Now you'll see that the halves cancel, and the K's cancel. So we're left with AP divided by PB. Now we could have actually gone straight there without putting in the formula here, because we know from the previous video that if two triangles, there's my triangles, if two triangles have the same altitude, so they have the same altitude K, then the ratio of the area of the triangle, so the ratio of the area of APQ and BPQ, equals the ratio of the bases. So the ratio of the bases is AP over PB. That's because they have the same altitudes. And the same altitudes come from the common vertex. So your reason is common vertex. Now I'm going to do the same thing, but this time I'm going to divide the area of APQ by the area of PCQ. Now notice those two triangles share the common altitude H. And the base of the first triangle is AQ, and the base of the second triangle is QC. So I'm going to do the exact same thing again. But now I'm going to say the area of triangle APQ divided by the area of triangle PCQ. Again, let's look at our formula. Half times my base, which is AQ, times my altitude, which is H. divided by half times by my base, which is QC, multiplied by my altitude, which is H. Again, my halves cancel. Now my H's cancel, and I'm left with AQ over QC because they share the same altitude, which comes from a common vertex. But now the area of triangle BPQ and triangle PCQ, they have equal areas because remember they've got a common base and they've got exactly the same height. So if they've got a common base and the same height, their areas are exactly the same. So I can write, but hang on a second, area of triangle BPQ is actually equal to the area of triangle PCQ. Those are my triangles that are sitting in my denominators. So I know because those denominators are not equal and the numerators are common because they're both area of triangle APQ. Therefore, that whole thing there must be equal to that whole thing there. So I can say, therefore, the area of triangle APQ divided by the area of triangle BPQ is equal to the area of triangle APQ divided by the area of triangle PCQ. But hang on a second. That is equal to that, and that is equal to that. So if those guys are equal, then those two ratios must also be equal. So I can say, therefore, AP divided by PB is equal to AQ divided by QC. Now I've just got to go back to one thing here. When I made the statement that the areas were equal, I should have put a reason in there. So maybe just fill that in. You've got a common base. Remember we said they had the same base and they had equal heights. So common base and equal height. And our proof's now complete because if you have a look, we've concluded what we were required to prove. AP over PB is equal to AQ over QC. So we've proven the parallel line theorem.